How the number of uses of a commodity affect the elasticity? Again, we can take two simple examples, say electricity and say petrol. Electricity you are using at home, say for lighting, say for entertainment, say for washing. Petrol you are using only to run your car or your any other vehicle, right? Now suppose the price of this electricity falls. What you can do? You can increase the number of uses, right? I can use it for cooking even. I can use it for cooling even. For ironing my clothes. Okay, so it means the demand has increased. So if the commodity has many uses, its demand is said to be elastic, right? Because if the price of the commodity falls, consumer will increase the number of uses, and in case the price rises, he can cut down the uses, he can decrease the uses. But now look at petrol. Suppose the price of petrol falls, but I'll buy the same amount of petrol. It is not that I'll start going from a longer route, right? Consume the same units of petrol, same amount of petrol. Similarly, in case the price rises, then also I am helpless, right? I have to buy the same units of same quantity of the petrol, right? So if the commodity is single use, the demand is inelastic. Okay, so this is this particular part is very important. The question is often asked from any of these determinants of elasticity, right? So whenever you have to explain, you use these keywords. This should always be, for this point, these are the keywords. When it would be elastic, when it would be inelastic, that you have to mention, right? Now after discussing about the factors of elasticity, we move on to the degrees of elasticity. Okay, see, there are 5 degrees of elasticity which range from 0 to infinity. Okay, and they all are defined on the basis of the response of demand to the changes in price. First, we will start from a perfectly inelastic demand. Or mathematically, ED is equal to 0. It means that the demand cannot or can't respond to any changes in price. Practically, there is no commodity which has perfectly inelastic demand, but yes, you can theoretically use the example of a salt, where we have already seen, even when the price was changing, the demand for salt was not increasing or decreasing. Diagrammatically, it can be represented. Again, I take the quantity demanded on the x-axis, the price of the commodity on the y-axis. You can see that the price may be OP or maybe OP1 or maybe OP2. The quantity remains the same, right? Price is changing, but quantity remains OQ, perfectly inelastic demand, right? For defining it, you have to use the words that it is the demand which does not respond to any changes in price, or you can simply say when the demand cannot respond to the changes in price, it is known as perfectly inelastic demand, right? Second is relatively inelastic, or you can simply call it as inelastic demand. Mathematically, ED is greater than 0 but less than 1, right? It means that it is more than 0 but the value is less than 1. When I define it as when the percentage change in demand is less than the percentage change in price, or I can say proportionate change in demand is less than the proportionate change in price. Remember, all the other two degrees will also be defined on the basis of these two things, right? In the next one you will have equal to, and in the elastic demand you will have greater than. So you should remember, it is simply defining the how the proportionate change in demand is related to the proportionate change in price. It simply says that say suppose the price of the commodity changes by 20%, the demand changes only by 10% or maybe 19%, less than 20, right? Because remember the formula, ED was equal to percentage change in demand upon percentage change in price. So if you will put the value, you will come to know that here the elasticity will be less than 1. Then diagrammatically again we can just have a look, and diagrams are also to understand how you draw the diagram. If you understand one, you can draw all. Again you have the quantity demanded on the x-axis and price on the y-axis. Here first you mark your price and quantity. Right? Now suppose I am reducing the price. So demand should rise. The basic idea is that this change in the price, proportionate change in the price should be more, and this proportionate change in the quantity should be less. This gap should be more and this should be less. It shows relatively inelastic demand. Or on the diagram also it is visible that percentage change in demand is less than the percentage change in price. Join these 2 points, and this is the curve for the relatively inelastic demand. So next 2 diagram also on the same logic. Then we have the third degree, that is unit elastic. Or unitary elastic. Here we say that ED is equal to 1. It means that the percentage change in demand is equal to the percentage change in price, right? If the price changes by say 20%, demand also changes by 20%. Again, if you apply the formula of ED, then you will get it equal to 1. Again, diagrammatically also we can represent the unit elastic demand the same way. Again, you first mark OP and OQ. Remember, here we have the price, here we have the quantity demanded. Now this time I should try and make equal gap between P1 and Q1. And you can use your scale for that. Again, you join these 2 lines, these 2 points with a straight line. This is your demand curve depicting unit elasticity, right? Again, you just have to remember this. This is the logic. Then next is the 4th degree of elasticity, that is relatively elastic. Or simply you can call it as elastic demand, where ED is more than 1 but less than infinity. Here we define it as when the percentage change in demand is more than the percentage change in price. Means demand can respond more. Say if the price changes by 20%, demand changes by say 25%, or any number more than 20, 21, 22. Again, when you will apply the formula of ED, you will see that ED will be more than 1. Again, for the diagram we use the same logic. This time the gap between the quantity axis Q and Q1 would be more. Now again you can see that means change in the quantity is more than the change in price. So you have to just remember this logic for the three diagrams. Next and the last degree of elasticity is perfectly elastic demand. Or ED is equal to infinity. It is defined as when the demand keeps fluctuating even at a constant price. When demand keeps changing even at a fixed price. Again, practically you do not have any such situation. Here you can see the price OP, quantity may be OQ, maybe OQ1 or maybe OQ2. So demand is changing even at a fixed price. Now one thing to observe from all these degrees of elasticity, you can just refer back to your diagrams, that when we started making the elasticity, the first degree of elasticity, it was like this, just to remind you, ED equal to 0, perfectly elastic demand, right? But as we increased our degrees, what happened? The big curve became horizontal line, right? So we say that this is the slope. Slope, practically slope means what? The steepness which you have to climb, right? So as the elasticity is increasing, the slope is decreasing. You can simply understand it is most difficult to climb this particular type of a curve. But if you try to climb the others, it becomes relatively easy. While walking on this one is the easiest, right? So it means that slope and elasticity of demand are also related. That also we will study. But first we can have a look how to draw all the degrees of elasticity on a single diagram, because the question may be asked where